Lesson 3.5 has two main objectives. One is to model data using exponential and logarithmic functions. They're also going to introduce a new function called the logistic function. And the second one is to linearize and analyze data. In order to model data using exponential and logarithmic functions, they're going to give us some data. They're going to put it in a table or a chart. We're going to put it into our calculator, into the stat. We're going to put it in the list. We're going to look at the graph, and from that graph we're going to make inferences on what type of model we believe it is. So we're going to use a little bit of our own visual acuity here to figure out what kind of graph we believe it is based on the shape of the graph and also based on the context of the problem. Sometimes that lends itself to us picking the appropriate model. So this is nothing new for us. We've done a lot of this where we've modeled data and we've picked the appropriate regression to model the situation well so that we can predict from there. So that's kind of the setup for what we're going to be doing. First thing I was going to look at is just a quick little tidbit here, and it's just, why do lumberjacks make such good musicians? And if you think you know the answer to that, let me know and we'll discuss that. But why do lumberjacks make good musicians? Alright, getting into our investigation here. Exponential, logarithmic, and logistic modeling. We have never had logistic modeling, so that'll be a new one, but the other two we've looked at before. So in this lesson we're going to make exponential regression features on a graph and calculator rather than algebraic techniques to model data exhibiting either exponential or logarithmic growth. And it could be growth or decay. In our first example, we're looking at an internet example. The internet experienced rapid growth in the 1990s. The table shows the number of users in millions for each year during the decade. Use exponential regression to model the data. Then use your model to predict the number of users in 2008. And let x be the number of years after 1990. So first thing we're going to do is we're going to put this information into our calculator. We'll put it into our stat and our list. And then we're going to do an appropriate regression. Now this time they tell us what regression to use. They tell us very specifically to use the exponential regression. And that will be the case for several of the problems here at the beginning. And in the end, what they'll end up doing is taking away that set of instructions and say, you pick the appropriate model. So that's where it gets a little bit more interesting when you have to do that. So the first thing we're going to do is we're going to edit the data into our stat list. And what I did already, rather than taking the time typing in on the video, I've already typed it in. All that data is in list 1 and list 2. So stat, edit, list 1, list 2. Then we want to make sure we have an appropriate window to view our graph. So I chose a window which I think is appropriate. I went down to 0 for year 0, 1990, and all the way up to 2000 would be 10 years later. So I went up to 11 so I could see that. Also, I looked at the Y values. So the Y values, or the internet users, goes from 1 to 70, and we're talking about millions of users. So went up to 100, so I had enough room on that side. Next thing we got to make sure you don't remember how to do is to set up your stat plot. So we want to make sure that you get your stat plot on. So I'm going to go to question or stat plot number 1. I want to make sure that it's turned on. I also want to change the type. On these we want to see a scatter plot, and that's the first selection. Scatter plot, hit enter. As soon as you hit scatter plot, it takes automatic, has a default. X list is coming out of, or X list is your list 1, your Y list is in list 2, and that's exactly where I have the X and Y values listed. So I should be ready to go ahead and set up a graph. So I'm going to hit graph, and there is the path of our graph. Based on the shape of this graph, it looks like it's increasing at an increasing rate, so an exponential model seems to be an appropriate regression to run, and that's what they asked us to do. So now what we're going to do is we're going to go into our stat, we're going to hit calc, we're going to do a calculate, and from the instructions they said to do an exponential regression, so keep on cursoring down until you see the expo regression, and hit enter. Now it says it's getting the x's from list 1, the y's from list 2, that's all appropriate. There's nothing in the frequency list that we're going to do. And this calculator has a nice little feature that says store regression equation. If you do not have that, you want to make sure that you get your equation stored in Y1. So I'm going to store this regression equation in Y1. So I got to go to the vars. So find your vars key. You want to go to the Y variables because you want to put this into your Y equals. And we're always going to be working in the function mode, so you don't have to worry about that. So by default, we can go right to function, and here's where we can select where we want to place it. It's rather important you put these in here. The book makes a point of telling you, make sure you store the entire value. Don't round them off and put them in your calculator on your own. So we want these to be transferred into that list one, or Y1 equation editor as we do the regression. And now I can come down and I can ask it to calculate, hit enter, and it's going to run the regression. Okay, some things here that we really want to pay some attention to is, well, first of all, A is our first value here that we want to plug into our exponential growth problem. And A normally tells you the start at value. What did we start at? And this would be back in 1990. And B would be your rate of growth. So we look at about a 69% growth rate each year, since it's 1.69. And our R squared and R represent our correlation coefficients. How strongly does our regression fit our data? So now this equation should be placed in Y1, and that's where you see that is part of that value. And you can see the rest if you cursor over, I would imagine. But that's the equation that it's going to graph. I'm going to graph that onto the scatter plot, and we'll hopefully see a fairly good fit or correlation. Our correlation was pretty high. Perfect is a 1. We have a correlation of 0.99, so it is a good model to predict how well it's modeling the data. So this is the first thing that we were supposed to do. We were supposed to find an appropriate model, and now we're supposed to use your model to predict the number of users in 2008. And we're going to record that equation as well, but before I do that, I want to go figure out in 2008. So how many years later would that be starting at? I believe they said years after 1990. So after 1990, that should be 18 years later. So what I can do is I can just simply hit trace.
Margarita Valdez, please come to the office. Margarita Valdez, please come to the office.
And now, right now it's on plot 1, which is list 1, list 2. I don't want to do I don't want to use that for my answer here. I need to make sure that if I'm going to do the prediction, I got to be on my prediction line, which is our curve in Y1. So type in 18, and after 18 years later, okay, I didn't like that because here's the problem that I have with that. I did not go out far enough on the x-axis, so I'm going to have to change the window, and I got to get out there more years than 11, so I'm going to go out there 20 years and make sure I can get that to fit. And maybe because of that 20, I'm going to increase the scale by 2. We'll hit the graph again. We should still get a pretty decent model of this. And now maybe it'll allow me to go and trace 18 years into the future. So 18 years. Enter. Oh, where did it go? Looks like we're having some technical difficulty. Quit. Clear. Go back to my graph. I want to make sure I know what I did wrong there. I didn't get down on my linear or my exponential graph. Now I can probably trace that. Come on, get down there. Okay. That's not funny and fun at all. It should be allowing me to go in here, and now I should be able to trace on that. So let me problem solve this quickly. How do we get there? Did I not get the window reset? The window's reset. Let me see if I can figure this out, and I'll get back to you on this. I didn't anticipate this being any problem here. So, well, when I went and tried it, after messing up a couple times, it worked just fine. So we'll try it one more time. We want to know after 18 years later, what will the number of internet users be? So I hit trace. Going to go down to my equation Y1. Now I'm going to type in after 18 years. Looks like it's allowing me to type it in, and there's the result I was looking for. We should have 5,985.66. Now this is in millions, so that's going to increase that number quite a bit, but that's what we're going to record. So what we want to be able to do is we want to write our equation, and I'm just going to round it to the hundredths place here. When we ran our regression, sitting in our equation Y1, we had an equation that was 4,400 approximately times 1.696, I believe, if I had that written down right, to the x power. There's our exponential growth model. And in about 18 years, so approximately, or what we could do is we could do, say in 18 years, it's about okay, let's go get that number again, 5.985 million users. Billion users. Okay, so that's some of what we're going to be doing. It's going to be very calculator generated. Hopefully we'll be calculator friendly, and we'll be able to run these regressions and make some predictions based on our regression curve that we've found.